What's going on, smart people? There is less than a month left of classes. Just let that sink in for a second. The semester is actually winding down. Or I guess it's kind of winding up when you think about the fact that finals are coming. Anyways, NMSU finally posted the classes that are available to be taken next semester, so I figured I'd go over the classes that I'll be taking, assuming I get into the Ph.D. program, but let's not talk about that right now. This semester I'm taking Quantum Mechanics 1, Classical Mechanics, as well as Mathematical Methods. Quantum Mechanics 1 kind of gives away the fact that it's a multiple part course. There's 2 parts to the course, which already means I already knew what one of the classes I'll be taking next semester is. I'll be taking Quantum 2. This semester we covered a good amount of things. We covered your Schrodinger equation, your different pictures of quantum mechanics, the time evolution operator, and it looks like we're going to be ending with addition of angular momentum, but I don't think we're going to be finishing it this semester. That's going to spill into the next semester, and then we might do things like perturbation theory, variational methods, some scattering. I'm hoping we'll get to maybe some quantization, or at least the Dirac equation. That's what I'd like to get out of next semester quantum, because that would finally be getting into a quantum mechanics that you're not formally taught in undergrad. So I'm really excited for quantum mechanics 2. The next class that I'll be taking next semester is definitely not experimental physics, advanced computational physics. This I'm super stoked for because I haven't done any coding in a while, not since over the summer when I was in my research internship for nuclear theory. So I really miss it. In undergrad, we had our computational physics class, and we did things like root finding algorithms, taking derivatives and integration. What else did we do? Some Monte Carlo, as well as solving differential equations. The differential equation solver we used in undergrad was fourth order Runge-Kutta. I don't know if that's what we'll be doing here. Let's take a look at this. Advanced computational physics, advanced treatments. Okay, so we got to go to undergrad to see what they covered, which is, oh, I already have that tab open. An introduction to finite difference methods, Fourier expansions, Fourier integrals, solutions of differential equations, Monte Carlo, and advanced physics problems. So it seems like it'll be pretty similar to what I did in undergrad. If you go to the grad, it says recommended knowledge of Fortran and C. I spoke to some people. It said that really any programming language you're comfortable, you can apply to the computational physics course. So I'm definitely going to be using Python. I might try to make myself do some of the stuff in C++ just to make sure that I'm not forgetting it. But Python, it's so user-friendly and it's so nice to use. Like anyone can learn Python really, or anyone can be halfway decent with Python. Just like any programming language, getting good at it obviously takes a lot of practice, but everyone I've introduced Python to genuinely loves it. So I'm excited for this. Fourier integrals and expansions. I'm not quite sure what that means as far as computational goes. If it's really just like, for I in range, add up a bunch of sines and cosines and then find me the coefficients, that doesn't sound too difficult, but if it's given a certain signal and then decomposing it into frequencies, that actually sounds really, really cool. I'd like to go deeper into Monte Carlo, maybe Monte Carlo simulations if it ends up getting to that. I don't quite know. So I'm really excited about computational physics. I need more of that in my life. The final class is, let's go back to the grad school. Let's go down, statistical mechanics. This one, I'm a little half and half on. It's not my favorite subject, but I only took one course of it in undergrad, whereas, you know, in undergrad you might have Classical Mechanics 1 for your intro, and then the advanced class, and then take it again in grad school. See, it's like multiple iterations of the same class. The same thing goes for like quantum, where you have your modern physics, then your 2 semesters of quantum, and then grad school. So certain classes they emphasize more in undergrad and in grad school. StatMech is just one of those things I've only been exposed to one time, and that was for thermo/statistical mechanics, so it was kind of split down the middle for both of them. So I could definitely benefit from taking another course in it, especially since for undergrad I think the emphasis was more so for thermodynamics, just because when everyone took thermodynamics in undergrad, not everyone had quantum yet. So if you got into statistical mechanics, you really couldn't get into the quantum statistics, which is a big part of the course. So they really just ended up emphasizing a lot of thermodynamics. We ended up talking about microstates and all that stuff, but I don't think we went that deep into it. We did talk about things like the partition function and whatnot, but so for this class we'll be going, it looks like a thermo review, which is good. I think it wouldn't be too great to just be statistical mechanics. I think there's benefits to talking about things macroscopically and, you know, tethering it to that. Probability, entropy, equilibrium, canonical and grand canonical ensembles. I don't remember grand canonical. Remember canonical, but not grand. It's also my favorite word. Classical and quantum statistics, degenerate and classical gases, an application to the equilibrium properties of solids, liquids, and gases, kinetic theory, and transport processes. Who knows if we end up actually covering all of these things? If you go up to the quantum mechanics, actually no, classical mechanics, it says that canonical transformations and Hamilton-Jacobi theory, but in classical mechanics, I don't think we're actually going to end up getting to this, because it looks like we're ending up on Hamiltonian formalism and canonical transformations. I don't think there's enough time to get to this. So everything that's listed in these course descriptions doesn't necessarily mean that that's what we're going to cover. For example, I think in our thermodynamics class in undergrad, it said kinetic theory, but we never really covered kinetic theory in my undergrad class. So I hope to cover it in grad school, but we'll see how that thing goes. Thermodynamics and statistical mechanics, it's not a particularly exciting course for me. I don't think it is for too many people. Even one of its pioneers, Boltzmann, ended up, killing himself when he did statistical mechanics. Who knows if that was the reason? But then a student, what was his name? I don't remember. It starts with an E. He became like a master of statistical mechanics, just like his teacher, and then he ended up killing himself. So statistical mechanics is not one of those things that I guess people are too fond of. But I think Einstein had a very, very high opinion of statistical mechanics. He also did his work in like Brownian motion and stuff like that. But StatMech, I'm excited just to get another exposure to that class. The other two classes, quantum and computational, those are just awesome courses. I can't wait to do some perturbation theory again and variational methods, go deeper into angular momentum. When I was in undergrad, I know there were notes available for things like spherical tensor operators before we were doing the angular momentum. Hopefully we might get into those in grad school, but who knows. And also, like I said, I just need some more computational in my life. It's just one of those things where you're like, there's something missing. Some people look at the kitchen table with their significant other, and they're like, someone's missing here. We should have a child. For me, that thing that's missing is definitely computational physics. But that's what it looks like I'll be taking next semester. I'm pretty excited for it. This semester, I was really excited for all my classes except for one, which was classical mechanics. It ended up being actually pretty fun, and I got a lot out of this class. So I'm not too excited for statistical mechanics, but who knows? It might end up being the exact same situation where I get a lot out of it. Who knows? Let me know out of these three classes which one you think sounds the most interesting. Also for next semester, for whatever you're taking, what are you excited to take? Let me know in the comments section. I'll see you guys there. I'll see you tomorrow.